We are official. Welcome to the virtual meetup benchmarking Apache Druid. And before we get started, we're just going to go over a few rules of virtual engagement. Everyone will be muted to start because we're going to be recording this meetup just to avoid some feedback. Please save your questions for the end if possible. You can then unmute yourself to ask a question, or you can put it in the chat box if you prefer. And also, after every one of our virtual meetups, I'm sending out a link to a short event survey. I send it via meetup.com. And if you complete it, you'll have a chance to win a $25 Amazon e-gift card. Survey link is right here. It's a bit.ly link /Druid meetup, but I will be sharing it via Meetup. And a lot of you have been asking, how can you get involved with the Apache Druid community? Well, there's several ways. You can add Druid as a skill on your LinkedIn page if you haven't already, please do. You can always contribute on GitHub. You can also add your company in the use case on our Powered by Apache Druid page. You can find us on Twitter at Druid.io and follow the Druid project there. You can find us on ASF Slack and ask all your questions there. We have 36 Imply-owned meetup groups now, so you can find one hopefully in your area. And if not, we are doing all these meetups virtually right now. And if you have any questions, you can always connect with someone on the community team by emailing us at community@imply.io. And now for why you're all here. Nice picture of you there, Matt. Everyone meet Matt Sorrell. He's our speaker tonight. He's my colleague. He is an Apache Druid evangelist at Imply, and he's an excellent technologist. He serves as an educational resource for developers building high-performance, real-time analytic apps, and he's built products at dozens of tech companies. You've already read his bio on the meetup page, so I won't go into all the details, but he's awesome, and I am going to turn it over to him now. Thank you, Matt.
Oh, thank you very much, Yelena. That was a great introduction. Let's see. I guess first I want to tell everyone before I start, I am in fact wearing my Imply t-shirt. You know, we have to, you can't see it. Okay, so now let's see, I go to slideshow. Okay, and oh, I hate this. The PowerPoint slideshow shows up on different screens every time. Oh, I'm going to start sharing. And benchmarking Apache Druid, screen 3, share. Okay, everyone. Now, first, before I start, I want to, it's funny, I look like I'm looking up because my monitor is in fact up. Okay, so before I start, I wanted to just thank everyone who helped me work on this. I started at the company at Imply, having really only played with Druid a little bit in January. And from that point on, I had to get up to speed pretty quickly and learn enough about internals to start benchmarking. And so really, I would be nowhere if I didn't have the help of a lot of our fantastic solution architects, some of whom are like, I see Ben Hopp is on the call. Thank you very much for all your help, Ben. Ramel Garcia was hugely helpful. Sareka, who was on the community team, helped me a lot, as well as did Rachel Podreski, who runs the community team. And Gian Merlino was a tremendous help as CTO. I mean, really, if you want to performance test a product, asking the guy who wrote it about how it works is a pretty good way of learning internals. So with the thank yous out of the way, let's see. So one thing I want this talk to be about, I want everyone to walk away from this talk with an idea of how they can test Druid in their own environments, because that's what really matters. Look, let's be honest, like Druid is super fast if you ask it to do the right things. If you start asking it to do things that it wasn't built for, you may be disappointed. And so part of why I wanted to do this project was to help understand what Druid is good at and how people can do this testing themselves. So what I would like you to leave here with is how you can replicate Druid benchmark in your own environment using your own data and your own queries for your own use cases, because that's what'll really have value. Like if I just tell you, oh, we ran some queries and we got millisecond response time, does that even mean anything? It really doesn't. Performance only means something in context. And so my goal here is to give you the tools to establish that context and gain those insights for yourself. It's interesting, this benchmark, like marketing latched onto the benchmark and the results. And I don't think the results are nearly as helpful as just understanding what the benchmark can teach us about how Druid works and how Druid works on individual workloads as well. So just to give a quick overview of the company, because I do work for Imply, even though this is Druid. Imply was founded by the creators of Druid, FJ, Vad, and Gian, three like super intelligent, really easy to talk to guys. We've got funding, we have customers, they're really big customers. And I guess the only point of this chart on the bottom right is that it's going up, which is great. We want all tech companies' charts to go up, especially if we work there. And Imply makes a bunch of products that all fit together. But what I do is focus on Druid. Druid is the analytics engine that powers the Imply solution. And like I said, it's super fast and people are running it all over the world, primarily because the query speeds are so fast that they actually are changing the way people work by building more exploratory workflows, which is possible because they have snappier results. And I don't know about this make data fun again, but maybe it's happening. I think data was always fun. Okay, so if we look at Druid, I'm just gonna run through a couple of slides. I realize we probably know what we're talking about because this is an advanced topic, benchmarking, but let's just start so we have a good basis for comparison here. Druid does real-time ingestion. It's very flexible, full text search. It's a time series database, which is actually really important when benchmarking or in designing any query, is just understanding that Druid is in fact time-based. And when you work with time, you will get faster responses than when you are asking questions about things that aren't related to time. And Druid is also super well suited for OLAP, which is what we tested, using batch ingestion rather than real-time or streaming ingestion. Anyway, let's just keep going. I covered a bunch of these. It's column-oriented, high concurrency, very fast response time. So we talk about Druid a lot in this terms of this real time, but I actually wanted to take a step back and answer some questions about data warehouse type data first, and I'll explain why. But a lot of our customers use Druid to subscribe to Kafka feeds and like run analytics on real-time data. We chose not to do real-time data for this. We'll get to real-time data later. So a lot of where Druid lies in your architecture is typically, I mean, I just described how like getting real-time data into Druid. You usually have a number of different, I like how I'm pointing at my monitor. You'll have a number of different data sources. They come in and they get basically staged and processed to be in a format that Druid can read. And then you'll run Druid to house the data and write your applications to go to query against Druid. And that's pretty much what your average pipeline looks like. And it breaks down into, this is how Druid actually runs. The data servers house, guess what? The data. Query servers will run your queries. The master servers coordinate it all. And so each one of these little boxes kind of runs as its own separate process. So it scales in a cloud native fashion, process by process, totally devoid of this single server dependence for an entire stack, which is another great thing for benchmarking. As far as external deep storage goes, we rely on, well, at least for this project, I relied on S3 for deep storage. Okay, so so you've got these servers, masters, queries, query servers, and data servers, and you have to decide what to install Druid on. Typically, right, your data node has to be big enough to hold your data, and you want to look at having CPU, heavy CPU on your query nodes, and a lot of memory. And also with your data nodes, if the faster disk made a difference too, having local SSD. And so when we did this test, we deployed onto, actually what we did was deploy into Imply Cloud to run Druid, and we configured thusly. So this is actually sort of important because I could have thrown any hardware at this that I wanted, given that I work for the company, and just gotten a faster result. But what we did was actually this was in the early days of the program when Ben was working with me, and we tested across a bunch of different size data nodes and found that we could spend more and get better performance. Performance scaled roughly linearly with cost across the data nodes, which was pretty interesting. Also, I guess I didn't mention at the very beginning of this that this benchmark was kind of all I did. I lived and breathed this thing from about the end of January until a couple of weeks ago. So I may make little passing comments that don't seem significant, but are significant because it's just all this like gook in my mind regarding a benchmark. Anyway, so a lot of people who use Druid focus on streaming ingestion. So I threw this slide in here for reference. It's not really the point of this testing. In this testing, we focused on batch ingestion, and we ran batch ingestion in parallel. And actually, we imported a tab delimited file. Druid's got, well, I'm not selling Druid here, but Druid can really import a whole bunch of different stuff. And you can play with it. Play with what you're importing through your ingestion spec. And I'll show you that in a couple of minutes so that you can align what you're importing with your anticipated queries. So a lot of this comes up like, what's Druid good for? And I'll tell you, it's good for working with a large data set where you need a really fast response time, and you can invest the time in getting your data to be in such a way that Druid loves it and works on it super fast. The reward is just like lightning fast performance. And I guess one of the things that where this matters a lot is, like, let's say you have a dashboard. If you have like one person who sits down, there's only so fast they can write their queries. Okay. But if you have a dashboard and you may have a dashboard that loads 10 queries every 5 seconds, right? That becomes a lot of queries pretty quickly. And now you have 5 people, 10 people, 100 people running it. And now all of a sudden, performance and at concurrency, it becomes really important. And so these are the ways that we try to line up Druid with workflows. Okay, so now turning to this work. One thing that Rachel and I talked about when I came on board was that this feeling that no one has really fully characterized performance of like this of databases like Druid, like sort of custom built, screaming fast, column-oriented time series databases. There have been little bits and pieces of tests done, but there's really no, as far as I know, and feel free to email me and tell me, there's no like definitive test to say this is the fastest database. I mean, and I happen to know that, oh, I didn't tell you guys my background. I happen to know an awful lot of benchmarking. So I worked at, I built benchmarks for 4 years and ran benchmarks. I worked at PC Mag Labs from 2000 to 2004. And there's a lot that you can, like, just because something's a benchmark doesn't mean it's real. Rachel, what is it you say?
Those lies, damn lies, and benchmarks.
Yes. And I've known Rachel for years, and she says that, and it makes me angry every time. But it's true. And I'm telling you, it's your job. Like, no, it's not the vendor's job to tell you the truth in a benchmark. It's the vendor's job to portray their product the best they can. It's your job to read the benchmark and understand if it applies to your workload and your queries and decide, like, honestly, if it's just a bunch of garbage or not. So we really want to go about this and do this, like, you know, the right way, or at least a logical way. I'm not saying that there's one right way. Anyway, the idea here is to loosely follow the enterprise digital transformation journey and characterize performance along the way. So the theory here is that as companies think about using new architectures or solving new problems, they start with a frame of reference, and that is what they already have. And so that's actually why we chose to start with SSB, the Star Schema Benchmark, because this helped us to evaluate Druid's performance in the context of the data warehouse. And we feel like this is a large, like, people understand data warehouses and how, and the way they use them and the performance they expect. So the goal here is, right, we say, okay, you understand this. Oop, you can't see my hand because of my background. You understand this. Okay, we tested Druid just like this. Okay, oh, are you thinking about moving to a streaming architecture? All right, well, our next test is going to be Druid on a streaming architecture. And then, right, so we're paralleling the digital transformation journey so that we can provide, like, key information to like enterprise architects as they decide what to do. And in doing this, we're we've chosen to use widely accepted data sets. SSB is a data set and a set of queries as well. And what we really want to do is really nail down and characterize Druid's performance. So if you ask anyone, you get the answer, Druid's really fast. Okay, well, how fast is it? And what we're trying to do is talk about how fast it is in various use cases. I left out the punchline, which was our end goal here is that we want to develop a new test that draws upon existing tests and define a new streaming OLAP test. Because this is a direction where it really seems like a lot of businesses are headed, the real-time data analysis. So first we'll show how we compete it in this data warehouse use case, and then the streaming use case, and then merging them both and showing a streaming OLAP benchmark. It's just going to take a year, that's all. So there are some similarities and some differences between Druid and other data warehouses. I'm not going to read the whole slide, but basically, I tested Druid using SSB queries, which are data warehouse queries, but I want everyone to know that Druid is not a data warehouse. Druid does a really good job in analytics, providing sub-second response times on queries. It's not a traditional data warehouse architecture. Now, it can be used as part of a data warehouse architecture. So this is all going to come together in a couple of slides. Bear with me here. So this is an example of a customer that we have, and basically what they're doing is taking event data from a whole bunch of different origin points and different systems, bringing them together, either working with them as Kafka streams or running an ETL process, and then putting it into Druid, this big thing on the right that says Imply, it's actually Druid, and then building their dashboards or their alerts or triggering their machine learning off of that, okay? And what I did was generate the data in EC2, save it to S3, ETL it using Athena, thank you, Ben, and then load it into my clusters. So actually what we did in this was we tested Druid to characterize Druid's performance, and then like almost as a control, I ran some tests against BigQuery because BigQuery's performance is already well understood. Okay, so we have this data warehouse, and I guess I want to make sure that I already made the point that like you would not build a data warehouse with Druid, but you would build a data warehouse with something else and then run analytics over it with Druid, which is why query speed is so important. Okay, so if we turn to the SSB, I have a link there if you want to download it. This is a test that it's based on TPCH from the Transaction Processing Council, which is another kind of these. They make these large enterprise database tests. Sort of the classic TPC would be like who could process more transactions per second, SQL Server or Oracle. Like that would be like your classic TPC test from 1990 or something. So they took TPCH and they stripped it down and they changed a bunch of fields to simplify it. They made this thing called the Star Schema Benchmark, and that's really caught on at this point far more than TPCH. Oh, I actually forgot to include this in a slide, but there was this group, these guys, that you can't see it. There was a group in Portugal, Professor Correa challenging SQL on Hadoop performance with Apache Druid. They had done this study last year, and they used SSB. So that was one of the reasons I wanted to use SSB to help build on their research instead of starting over. Part of the point is that if all these things are tested using the same data and the same queries, then their results are somewhat comparable. SSB allows, the runtime rules of SSB are that you're allowed to tweak the queries. So, it's not perfectly comparable, but in a working respect, it is comparable. The way SSB runs, you download this utility. I actually, on the last page of my presentation has links to all this stuff, including my GitHub repo with all these scripts, which I would super love if everyone went to and starred. Thank you. So if you run dbgen, you run it from the command line, you give it some switches based on scale factor, and it generates its 5 tables that are tab delimited. Line order is your main big table, and the others are just the dimension tables that go along with it. And we did this, we got a 6 million row table. No, wait, that's not right. 600 million row table. Wow, that just a little mistake on my slides. And that's roughly 100 gig file, okay? So at that point, right, these separate files, customer, supplier, part, date, they're all tab delimited and they're on their own. And basically I generated them on EC2, on EBS, and then I copied them over to S3, where I then used Athena, which is Apache Hive, to denormalize the 5 files into a single file, which I then saved in orc. So I loaded the orc extension in Druid and was able to import the file to ingest the file into Druid. I like how this one slide took me like 30 seconds to read, but far more than 30 seconds to actually do. Okay, so it's important to understand how when Druid ingests stuff, it lays it down into its own structure called segments. And these are basically, actually, you know what? It's easier to explain when I get to the ingestion spec, but it's like how Druid is thinking about the data, and it's pretty much based on date. Let's just cut to the chase here. It also builds its bitmap indexes, which help speed up queries. And we didn't use any rollups in this testing. The dictionary is encoded on the column level, which is pretty cool, too, in terms of accelerating performance. Not the greatest thing for conserving storage, but really good for speeding up queries. Now, when you read data into Druid, ideally, you want to end up with about 5 million rows in each segment. And it's like, it's easier to just sort of think about it. Like if you're going to ask a query of a whole bunch of different size segments, like if they're evenly sized, then performance is more evenly distributed across segments. So really, like, this is where it comes down to you have to understand your data and your use case before you even start. Like, this Druid is not the tool to just point at some data and see if you get anything. It's going to be much faster if you align your ingestion with your anticipated query use. Okay, so here are this is what I'm talking about. Okay, so your ingestion spec is JSON. You edit it, and So you set your segment granularity. I guess so. Here's my point, right? It's just very easy. Segment granularity. If my data is organized, say by minutes, and my queries are all going to be about hours, then it's not going to be as fast as if my data is all by minutes. I set the granularity to hour, and now I ask questions based on hour. Right? You can see that. I don't have to give a demonstration. And then you want to set the maximum rows per segment, so we end up getting segments that are all roughly the same size for more equal performance. This is what I was talking about, Druid partitions on time, which is super important. And you can then partition afterwards. And it's really important to understand this so that, oh God, I feel like I've said this 400 times already. You have to align your queries with your segments and your partitions, or you're not going to enjoy your performance. Okay, so to sort of talk this through, now the full ingestion spec is in the GitHub. Now here on the left, we've got the data schema aspect of this. Right, so this is establishing all of, sorry, I got distracted here. This is establishing, oh, okay, sorry, I'm back. Damn it. All right. So what we have here is this ingestion spec, which is JSON. It pulls in the data, right? This was SSB data 0. It establishes our columns, our formats, and all that. Okay, further down in the ingestion spec, we define our metrics, right? So this is where, and segment granularity. So now I'm talking about making this to year, because I know a lot of my, queries were about year or month. And so I knew that was what I needed. And actually super key here is this line kind of pretty much in the middle of the screen, the transform spec, where we transform time. So we basically told Druid, the field LO_order date is structured as year, month, date. And then Druid knows what to do with that time. Because before that, it didn't. It was just treating the time as a string. And if it doesn't know how to treat time as time, again, you're not going to get the performance that you want. On the lower right here, these are my, this is from the end of the ingest spec. And this is about tuning the ingestion, right? So this was where I was pulling the file, SSB data 0. And I wanted it ingested in parallel. What did it take? It still took about half a day to ingest this file. And that was, I forget how many processes were running in parallel. I ended up about 10 or something. Oops. Okay. Then after the data was ingested, so we used JMETER, great tool, and we ran JMETER. We took our queries and we ran JMETER against each platform's HTTP API. We turned the query off. We ran each query multiple times to make sure we were and then we averaged the results. I threw out the top and the bottom to get rid of outliers, all kind of standard stuff. And we come back and we ran all the 13 SSB queries. So we end up timing individual queries, and then timing them all together as a flight. It's important to understand these queries were designed around data warehouse use cases. They select, here's the queries. But basically each query, these are the queries in English. Each query selects from the table exactly once and then makes restrictions, is essentially how it works. And then as you go through each flight, they get more and more restrictive. So for example, like you could look at any of these flights, like query flight 4 is my favorite because it's like a what if scenario. So it's like starting and asking a question, then digging deeper, and then digging deeper. And so that would be 3 separate queries in JMeter. Okay. Again, this date and timestamp, this is absolutely by far the most important thing that you got to get this right with Druid. The date and timestamp need to align with how Druid looks at your data and how you're going to query that data. And then, just really quickly, like I will be following this up with a blog post about how to optimize SQL queries in Druid. But, the first one was this aligning the dates, using the right date, parsing the date correctly, and then filtering on the date how it was parsed. And then optimizing SQL expressions, like, anyone who was writing wants to write clean, efficient SQL. And this vectorize is key. Druid vectorizes results, or Druid vectorizes data, so it can run queries super fast. But if you are writing queries that can't vectorize, then it's funny, I feel like I'm going to say it again, you're going to have a bad time. And actually we're working on making all queries vectorized, which should be super exciting. And as an example, so here's the original query for 4.3. Now remember, there were 13 of these, and what we did was run it, look at the time, make a change, run it again, look at the time, make a change. Some changes matter, some changes don't. But basically, you could see we rewrote this query to use the Druid specific floor statement on the parse, right? Because just querying by year was not nearly as fast as querying by what Druid calls a year. Okay, so how do you understand that? In between queries, you could run an explain plan. This is just an example. It wouldn't say, select this or from that. It would be a different query. But my point is, you can use the explain plan, and you can actually look at it. And if the explain plan looks like a mess, then you better rewrite your query so that it looks like something Druid can understand. And that sounds so cryptic, but if you actually looked at it, you would see exactly what it meant. Okay, so turning now to JMeter, I guess I've talked a lot. So what we did in JMeter, we set JMeter up so that this first screenshot on the left is authentication to the API. The second screenshot, the one in the middle, is basically just saying use JSON. The one on the bottom here then says use HTTPS against localhost and hit this path, which is where the API is. So one thing about this localhost, which is sort of a neat little trick that Ben showed me, was that if I SSH into my cluster and I redirect the port, 9088, I can run JMeter locally to do functional testing and make sure everything runs and I'm not getting errors, and then copy my test plan up to the server. So you always want to run JMeter. You want to run JMeter with no GUI to get your results. The GUI slows everything down. So you'll run it right off the command line. But it's actually hard to build your test with no GUI. In fact, I would call it impossible, but I'm sure someone can do it. So I ran all these tests. I put the queries in. you can see them all listed down the left, Q1, 2, 3, 4, 5. This is what the queries look like actually in JMeter. This is the same query that I showed before. The first one is this sort of standard SSB query in SQL, and the second one is Druidified, if you will. And then basically all these things just like combine together, right? You just hit the little green arrow and it runs all, and it starts firing all your queries against your data, and it spits out results, which I then analyzed, and we ended up with this, which is our results. And again, Matt, the broken record Sorrell here, these results don't really mean anything out of context. Okay, so like I know what Q1 is. These are all asking. Okay, so but another thing that's super interesting here is what we did was we went to our engineering team and we discussed these results with them, and they're working on enhancing the query planning engine to vectorize more queries. So part of what came out of doing this test was within the next couple of months, we're going to see Druid start vectorizing everything. And I can tell you right now, informally, when you take query number 1, which is running in over a second, and you vectorize it, it runs in about 200 milliseconds, which is pretty incredible. Okay, so hopefully I've given everyone enough information to be able to do this yourself with your own workloads on your own environments. And I guess I just really want to emphasize that it's super important to test using data that you understand with queries that you understand, that you anticipate, because it's real. Like there's no point in testing if it's not real or applicable to what you're doing. It's harder to make it applicable to what you're doing because you have to really understand it. And you can make there dramatic changes in how you ingest your data. Like how you ingest your data will dramatically affect performance, how you write your queries, and the interaction between the queries and the way the data was ingested will dramatically affect performance. I talked about running queries against the HTTP API. Actually, since then, we've run all these queries against the JDBC driver to characterize performance that way. And again, like do this iteratively. So run your query, get your results, make your changes, run it again. Was it faster? Was it slower? What did you learn? Like, did you learn? One thing we learned that was super interesting was that if we ran the queries in native Druid, you would expect them to be dramatically faster than needing running through a SQL interpreter, and yet they were only slightly faster. So that was like a really great lesson to go use SQL instead of native Druid. And again, I have to tell you, when I joined the company in January, and Gian and Rachel were like, no, there are no tutorials. Just download a data set and do it. And that's the best. Well, actually, there are tutorials. It's just that for this, there are no super deep tutorials. So again, I'm going to tell you guys the same thing they told me, and you will probably dislike it as much as I disliked it. But the best way to learn about Druid performance with it is to just do it. Like just go out there with your own data and run JMeter against Druid and characterize your workload. Okay. And here's I'm at the end. I guess I would take questions now. Here's a bunch of links to our community stuff and downloading JMeter. This bottom link that's bolded is I've got the scripts ingestion script and the JMeter scripts and stuff in there. All righty. I would turn it back to you, Yamada, if we have any questions.
Looks like we just had a question come in on chat from Snaggy. I am running a real-time ingestion. Is it a good practice to set Druid late message rejection period to none 7 days when I have 3+ billion events getting rolled up every day on our granularity, and there is a possibility of late messages, say a week old? Does that hamper Druid query rollup segment performance? And how does Druid broker and historical cache work?
Oh, Rachel. That sounds like a great question for you.
It does sound like a great question for me. All right. Okay. Generally, late data in general creates new segments. So once a segment is created in Druid, it is immutable. So if you have any data that is coming in late, it's going to create a new segment, which can or cannot be a problem. It can be a problem if there's a lot of them. And if the data is really, really out of order, you're going to get lots and lots of segments. And just kind of like for us old people, you know, when you have a fragmented disk and we used to have to run defrag on our Windows machines, same idea, right? Your data is kind of all over the place, and that's a lot of I/O in order to get your query results. There is a concept called auto compaction that comes through and will compact those segments together. So basically writes a new segment from old segments that have the same time boundaries. But again, that is kind of like amortizing the cost of your write over time, because you're going to have to use those auto compaction tasks that are always going to be running in the background. So those trade-offs, it's not that big of a deal. If it's just a few pieces of data once in a while and they're not read a lot, then you're not going to see much of a performance impact. So how does the Druid broker and historical cache work? Fairly well. Any other questions? Okay. So broker and historical cache, Druid does query caching, result caching is what I'm saying. It does not do data caching. So the data caching is handled at the OS layer. So you're always welcome to use OS cache and make sure that that's appropriately sized. But in terms of any type of caching with Druid, it's always just query results. Again, if you have any other questions, you're welcome to ask in the ASF Slack channel. I think Itai put a link to that earlier in this chat, or send an email to the Druid user groups. I look at both of those at least once a day and try to answer as much as possible. The thing, little behind the scenes knowledge, if I don't have an answer to it, I usually ask our engineering team or ask our solutions architects. So it might take me a day or so to get a reply back, and that's only because I'm trying to get an answer from the organization. And then I saw next is the segments are like partitions in Hive or Cassandra. Sort of like a Cassandra partition. I'm not familiar enough with Hive, but similar to a Cassandra partition. More like an SS table actually in Cassandra, Richard. I would say that the like for like as a segment is like an SS table, not like a partition. At least in Cassandra. I don't know about Hive. Okay. So I think the next question is Matt. Nice presentation. Does benchmarking data involve time taken to download the data when you fire a query via HTTP? Is that expected? Ooh, that's a great question.
Wait, what was the question? Does
benchmarking
did it
data,
measure?
Yeah, take the time to download the data when you fire a query via HTTP, and is that expected?
Yeah, so normally it would, like the network latency, right? Normally there would be some network latency involved, and that would be measured, right? JMeter breaks it out. I was firing right from the query node itself to minimize that. And then I think the other part of the so each query returns, like the actual query is returned to JMeter, which is a good way of double checking everything to make sure that the results are accurate and that the query size is the same.
Matt, do you have time for a few more, or do you want to?
I guess so.
Okay.
Are there more? I can't see the chat for some reason.
Oh, really? You see,
I'm sure if Rachel can see it, I'm sure I'm just doing something wrong. But
yeah, in your bottom tray of Zoom, you should see a chat icon. Maybe you don't have it. Let me see the next one.
oh, maybe because I'm sharing my screen, I'm confused in the interface. You know, I don't spend enough time in Zoom.
To store JSON files of 2 or 3 levels, is it necessary to structure it, tabulate, to be able to console the information?
Is it necessary?
To store
I
JSON
guess so.
files,
We're asking about the structure of the JSON files.
yeah, to store JSON files of 2 or 3 levels, is it necessary to structure it to be able to consult the information?
I think they're talking about flattening it out. Is that, I mean,
Richer.
right? So if you're talking, yeah, I see that. I see the question. Let's try to keep the questions to the benchmark. So let's go back to the benchmark questions. All these are great questions, and I highly recommend going to our next meetup, which will be probably another Ask Me Anything with Gian, or asking questions in the Slack channel, or sending a message over through the Google groups. But let's keep the topics, since we don't have a lot of time, on the actual benchmark. So questions like, did the benchmark include regex filters? And I don't think it did it?
It didn't. It had actually, I could go back. It had a lot of it didn't have regex. It was really more of like select this and select that, wear this or group by this. It wasn't doing any. It wasn't really a bunch of super smart kind of fuzzy queries or anything.
But I would say it's trying to simulate a drill down from what I can from what I can see. It's like you have a query, and then you're going to drill into another level, and you're going to drill into another level, which is a pretty standard workload for an OLAP system. But the benchmark did not test any kind of cool functionality, or the type of queries that analysts would normally run with, like subqueries and case statements, all of that stuff. They were just very simple type of analytical queries, and that's because we wanted to try to keep the SQL as generic as possible and make as little changes to it. Also allow the query, because every query optimizer is going to be different in the way that it reacts to queries, and some may like a case statement in one place but not like it in another. We're trying to limit that type of functionality. But in terms of regex, searching for stuff is definitely a kind of a use case on its own, right? And something we could definitely look at in terms of like, how does this compare to search systems? It would be a different style of query. And then somebody else is asking about JMeter. They have 2,000 concurrent requests. Will add more brokers help speed up the query performance?
If they have 2,000 concurrent requests, and
that's
would adding more, yeah, that does seem like a lot. I want to know how that comes about. Is that a whole lot of dashboards, I guess? But I guess would adding more brokers be helpful? I would think so.
But okay, so
but there's more to it than that.
Yeah, let's break that down a little bit. So first off, I've been working with Druid for about 2.5 years now, with production customers. And even our largest customer, our busiest customer, only sees about 100 concurrent queries. So testing 2,000 concurrent requests is definitely overkill, mostly because queries come back so fast within Druid that the actual queries per second is a better measurement. But in terms of brokers have to do with historicals. So you're going to want one broker for every 10 to 15 historical nodes that you have. it's not necessarily 2,000 concurrent queries. More brokers might help. It's about as many threads as you can execute. So I would take a look at some of the documentation in terms of tuning threads and turning concurrent workloads, but then also ask yourself, do you really need 2,000 concurrent requests, or is that you know, for your use case, are you really going to have 2,000 queries all hitting the system at exactly the same time, all hit run at exactly the same time?
Because the interesting thing with Druid is that like their response times are so fast that it's actually concurrent request is not the easiest thing to do because they're getting answered so quickly. I'm not sure if that was clear. Anyway, testing using trying to load test and build up concurrent numbers of concurrent queries in Druid, I actually found to be fairly difficult because it kept answering stuff. So it was like, it can't be, if it answers each one so quickly, then the overlap for concurrency ends up being much less.
And then Harish asks, do you recommend or prefer enabling query metrics to measure performance over JMeter?
Enabling query metrics in JMeter or in, so what I did was I ran JMeter, and what I used for metrics was I looked at server-side stuff in Clarity. I looked at the server-side management tools. I didn't use JMeter really to troubleshoot, except for just looking at like query responses in JMeter and making sure they were accurate. So I looked at the metrics that I looked at on the system side were like CPU time and IO, and to look for whether the system was constrained or not.
Yeah, I would say for JMeter, the idea, one of the reasons that we're using JMeter versus the timings from Druid, which are super useful, is that we're trying to create a plan, we're trying to create a very scalable, flexible performance testing plan that can be reused. And JMeter is a really good tool for that, for now analyzing the results. If you're just looking at how long your queries took, those metrics are totally fine. But that wasn't necessarily the idea behind, you know, why we use JMeter over something else.
Okay, well, we're getting close to end time here, so I think we need to wrap up, but I'm going to include the link to the ASF Slack channel to everyone, so that way if you have additional questions, you can reach out to Matt. Matt, thank you for your excellent presentation today and all your work on this project, and to Rachel for answering some questions as well. Just to wrap up, I will be sharing the links to the recording and also to Matt's presentation as soon as, you know, we might just have to make a few edits, but we'll try to get that done as soon as possible so we can share that with you, and so you can share with your colleagues who could not be here. So I'm thinking Monday by the latest, we'll get that to you via meetup.com. I'll also post those links in ASF Slack and on the Druid IO Twitter page as well. Thanks, everyone.
Thank you, everyone. I look forward to hearing from you.
Yeah, it looks like you're going to have quite a few more questions, so be ready. Sorry we couldn't get to everyone's questions. Thanks again. Goodbye.
Bye all.